Hello, this project was based on implementing, extending and investigating the Xtoon shader by Barla et al. From 2006. The Xtoon shader itself was based on the stylized rendering techniques for scalable real-time 3D animation paper put forward by Lake in 2000, in which the shading for a character was based on a one-dimensional lookup of a texture, based on the dot product of the normal and light vector. Barla extended on Lake's work by using a second dimension in the texture, which could be accessed via depth, viewing angle, a Phong-like specular effect, in order to look up the second dimension. For this project, I further extended it to use a level of abstraction mapped directly to the character's UV coordinates and a proximity-based algorithm. In the first example, we can see a terrain scene generated with this texture in the bottom right hand corner, allowing it to fade into the distance as the scene gets deeper. By changing the texture, we can achieve a variety of different effects, including adjusting the granularity of the shading close up where it's nice and smooth to far away where it becomes abstract and cel shaded. You can also see this approach when it's applied to a model. From a distance it's cel shaded. There's quite a lot of difference between the different bands of shading. As we get closer, the shading becomes smoother and smoother until it's what you would expect to see. Likewise, that can be simply reversed, so it's abstract when you're up close and becomes smoother as you move away. In this example, we can see a view-dependent effect on a slightly different model, in which case the camera-facing faces are more abstract, which becomes smoother towards the silhouette of the model. Likewise, this can be easily abstracted and the exponent adjusted to move where the effect will appear about the model in this case, so the face is largely smoothly shaded and it becomes more abstract towards the silhouette. This can be further used for other effects, such as a easily controllable silhouette or rim lighting effect. It can be used to create a painterly-like edge detection effect, and also it can be used to create a view-dependent, almost heat-sensitive effect by simply using a slightly more abstract texture. In this example, the level of abstraction has been directly mapped onto the model, mostly around the face. So on the face it's quite abstract. Around the rest of the model, the shading will be determined by the top part of this texture, so it'll be nice and smooth, and again, it can be very easily reversed. Furthermore, simply by again changing the texture, you can achieve some other effects. In this case, as it moves away from the more abstract areas, it fades into the background color. Finally, we have a textured version of the previous model. This time we're mixing the shading from the level of abstraction texture with the diffuse color texture. In this case, the level of detail in the abstraction texture will be determined by the proximity to this moving target. And likewise, we can control the blending between the two. So in this case, you can see that the closer any of the models are to the target, the smoother the shading will be. As they move further away, they become more and more abstract. And likewise, just by changing the texture, we can achieve a variety of other effects. In this case, changing slightly the color which appears on the model based on its proximity to the target. So that's just some of the effects which can be achieved using this very powerful but very simple technique, and thanks for watching.